deep eutectic solvent with a percentage of water added to attempt to lower the viscosity a bit for testing in supercaps. This deep eutectic solvent, inexpensive, relatively easy to prepare, contains anhydrous zinc chloride and ethylene glycol. The ethylene glycol, fresh bottle, dried over sieves to remove any water overnight, in a 1-to-4 molar ratio. For every 1 molar equivalent of zinc chloride, 4 molar equivalents of ethylene glycol, 1-to-4 ratio. And after the deep eutectic solvent forms, I heat up to 80 degrees for about 10-15 minutes, stir well, and you will then form a homogeneous material, and it will remain a liquid at 20 degrees Celsius. Once it forms and cooled down to 20 degrees Celsius, I don't know the freezing point. I would have to look it up in the literature, but I'm working at 20 Celsius in the lab. This contains 4% distilled water additive. I note when I add the water, it doesn't immediately dissolve. I gently stir it. And as I said, this is to attempt to A, lower the viscosity for use in a supercap test, and to see if the material would be affected by that amount of water, the deep eutectic solvent, whether a heterogeneous mix would form, what have you. I'm interested, of course, in the water electrolysis overpotential. Now, if you're electrolyzing water to produce hydrogen-oxygen gases, you want to keep that water electrolysis overpotential down as close to 1.3 volts as possible. But with supercaps, I want to increase the water electrolysis overpotential because I don't want hydrogen-oxygen gases forming. Here we're at 2.5 volts, potentiostatic, constant voltage, and you see zero current. So in other words, I'm not producing hydrogen and oxygen gases. I have two sections, small sections of graphite felt electrodes. I also work with oxidation of graphite felt electrodes, but that's another experiment and another story. And I have a couple of pieces of silver-coated copper wire inserted into the electrodes. No gas evolution. Now, if I boost this up to about 2.6, 2.7 volts, I will begin to produce hydrogen-oxygen gases. So I'm fairly confident at this point that this deep eutectic solvent with water addition, water in DES, I think we call that WiDES, water in deep eutectic solvent. And we also don't have to worry about moisture from the air getting in till you seal the supercap. You know, choline chloride is a very common component in deep eutectic solvents. It is hygroscopic as heck. You go through living hell to keep it dry. And now they're finding that with a little bit of addition of water, that it's going to work okay in many cases as a supercap electrolytic solution. So anyway, I wanted to show you this. And as I said, if you go up to about 2.6, 2.7 volts, you will produce hydrogen-oxygen gases. So this is just one aspect of the supercap work we do. My main focus right now is on oxidizing graphite felt electrochemically and then applying composites And then I turn my attention to the either a CMC phosphoric acid gel, sulfuric acid CMC gel, 4 molar KOH CMC gel, or a deep eutectic solvent with water such as this zinc chloride ethylene glycol. Thank you for watching. As always, we'll keep you posted on our research. Bye for now.